satellite images reveal the beauty of the Earth, enable new insights in research, and provide important data for numerous applications. But what is most frequently observed on them? The answer: clouds plus clouds and more clouds. For meteorology, this is a real blessing. However, for continuous observation of processes on the Earth's surface itself, it is disruptive. However, there are satellites for which clouds pose no problem and which possess a range of features that make them important tools for observing our planet. We are talking about radar satellites. Unlike most Earth observation satellites that work with sunlight reflected from the Earth, radar satellites emit their own electromagnetic waves. Waves. In this long wave range of the electromagnetic spectrum, unlike short electromagnetic waves, are not easily disturbed by particles and gases like water vapor in the atmosphere. Thus, they can pass through clouds, and radar satellites generate their data from the echo of these microwaves. Satellite images through echo? Microwaves in space? How does that actually work? What radar satellites are there? And what characteristics and applications do radar systems have that make them such important tools for analyzing and understanding our planet? Radar satellites are active systems and differ precisely in this aspect, also from the normally passive optoelectronic systems that are otherwise used in Earth observation. Optoelectronic systems are based on recording reflected sunlight, primarily waves of the electromagnetic spectrum, between 380 to 780 nanometers, which is visible light, and wavelengths from 780 nanometers up to 1 millimeter, the so-called infrared. The waves used in radar are even longer than those of infrared. Microwaves include areas of the electromagnetic spectrum with waves between 1 millimeters and 30 centimeters long. Radar satellites therefore send microwaves in the millimeter and centimeter range to the Earth's surface and measure their reflection or their echo. Through active sending and receiving and the range of wavelengths used, radar satellites provide us with information independent of weather conditions. Specific information about land and sea. They provide data on soil parameters such as soil moisture, the terrain, and earth movements. Additionally, they track ship traffic, the development and movement of ice masses, and wave heights. All of this information is of great importance for research and year-round global shipping. Particularly noteworthy for some of the satellites is the accuracy of the measured altitudes, which can be in the millimeter range, allowing for the detection of the smallest changes in elevation. The spatial resolution of these active systems is already up to 1 meter, and current systems already provide every 6th day a new image of the same point on Earth. Spatial and temporal resolutions are thus quite comparable to those of multispectral satellites. The high repetition rate of the recordings also makes it possible to detect changes in the Earth's surface as quickly as possible. Important radar satellites include, for example, Sentinel-2 and 1B of the European Space Agency. These multi-talents are among the latest radar systems and are part of the European Copernicus program, which constantly provides up-to-date information on environmental and security-related issues and makes it freely accessible. For example, changes in volcanoes or ground movements can be observed. With the help of Sentinel-2 data, Norway has been monitoring, as seen here, since the year 2018, the smallest changes in the ground in the millimeter range. This way, threatening subsidence or landslides can be detected early. Terrasa X from the German Aerospace Center also provides data on soil and terrain properties. To improve accuracy, Terrasat X was connected with the identical model Tandem X. This created a system primarily used for the three-dimensional surveying of the Earth's surface. And with it, a global terrain model with very high accuracy could be generated. Its ability to capture structures on the Earth's surface and their changes very precisely made the satellite network an excellent tool for observing the development of urban areas and forest regions. In contrast to Terraza-X and Sentinel-2, which have a fairly broad range of applications, Cryosat-2 of the European Space Agency is a true specialist. Its task is the precise measurement of polar ice. With Cryosat-2, it became possible for the first time to comprehensively record the thickness of polar ice, and its successor continues to monitor the development of the polar ice sheets. For the holistic observation of our planet, active systems are indispensable, because they provide us with information that cannot be generated by passive optical systems. They can see through clouds and also collect data at night. This makes it possible to create seamless records of the Earth, including areas like the tropics, which are often hidden under a cloud cover. But above all, only with their help can structures and their conditions on our planet be captured in 3 dimensions. Climate change and rapidly advancing land use change are transforming our planet. Radar sensors help to capture and understand these changes. With the increase in drastic events and a growing world population, more and more populated areas are affected by geohazards such as landslides, flooding, and subsidence processes. To establish early warning systems and protect vulnerable people in a timely manner, active radar systems are indispensable. They provide us with important information for the study of our home planet and simultaneously ensure the safety of us all.